For decades, astronomers have had their sights on one of the most luminous and mysterious stars in the sky, Betelgeuse, a red supergiant on the verge of imploding. Scientists long thought its demise was near, they just weren't sure when. Now, the James Webb Space Telescope has recorded something few dared hope to see. The moment Betelgeuse started to explode. A star explosion, a shockwave from space, and a brief look at the universe's raw, unbridled energy. It's not another deep space find. It's a once-in-a-lifetime experience, the nearest supernova human history has ever seen. And what Webb uncovered is appending everything we believed we knew. Betelgeuse, in Orion's shoulder, is no run-of-the-mill star. It's a red supergiant, larger than 700 suns and roughly 20 times more massive. Astronomers have watched for decades as it has behaved erratically, expanding, getting dimmer, and exploding randomly. In 2019, it suddenly dimmed, prompting worldwide speculation. Was this the start of the end? Would it finally supernova? With Webb's unparalleled accuracy, the enigma only grew. For the first time, we're witnessing live signals of a star in collapse. Gigantic energy explosions, turbulent surface activity, and magnetic fields wrapped into chaos. Betelgeuse isn't just dying. It's experiencing a cosmic makeover. Webb has spent months tracking Betelgeuse, employing its infrared sensitivity to pierce layers that no other telescope could reach. The findings are breathtaking. Huge convective bubbles, some as large as Jupiter, are bursting on the surface of the star. Plumes of superheated gas are blowing into space at speeds unimaginable. Buried within the spectrum of light, astronomers have discovered a shockwave propagating through the outer layer of the star. This isn't a model or simulation. This is live physics of a supernova happening right before our eyes, and it's taking place just 642 light-years away. The majority of supernovae appear in galaxies well outside our own. But Betelgeuse is essentially the neighbor next door astronomically. Its final blast will glow so intensely, it may be seen in the daytime, outshining the entire full moon. But aside from the show, its proximity gives scientists a close, intimate view of a dying star. It's a front-row seat to watch a core collapse, the way life-forming elements such as carbon and oxygen are formed, and how a shockwave sculpts space itself. What Webb photographed is not merely a death. It's the very motor that powers life throughout the universe. The Betelgeuse supernova is not just a spectacular sight. It's the key to deciphering the secrets of galaxy creation, the origins of planetary systems, and the cosmic cycle of life. Webb's technology enables scientists to simulate the terminal stages of star life with an accuracy never before available. For the first time, we finally know what a star looks like when it's dying. And perhaps, and hopefully, have learned to be able to foresee the next supernova before its occurrence. More than a science breakthrough, this is a revelation. A unique moment in human history where humankind gets to see the machinations of creation itself. However, this supernova explosion isn't a secretive occurrence. Its shock waves travel through space, disturbing the interstellar medium light-years away. Webb has already observed high-energy particles spreading outward, warming surrounding gas clouds and distorting the shape of the star's dust halo. More incredibly, scientists believe the collapse could have initiated gravitational waves, faint ripples in the fabric of spacetime itself. If true, this would be the first direct association of an observed supernova with gravitational data and could change our understanding of how light, matter, and gravity interact at the cosmic level. As Betelgeuse collapses, one fundamental question again presents itself. What will be left? Will it collapse into a neutron star, a black hole, or something entirely different? Webb's observations indicate the collapse is not symmetrical. Irregularities in magnetic fields, plasma voids, and evidence of matter crashing back inwards suggest something more complicated. Scientists are now guessing at a transition object, a hypothetical shape that fits between a neutron star and a black hole. If Webb has actually imaged one in formation, it would be the first proof of this new type of cosmic body. Of course, lots of people have asked, are we at risk? The short answer is no, Betelgeuse is too distant to pose any harm to Earth. But the whole story is more complex. The blast will release waves of radiation, gamma rays, and expanding bursts of electromagnetic radiation that might affect distant clouds of dust, change star formation, and impact how we perceive light from other regions of the universe. For the time being, Webb continues to monitor the velocity and direction of the radiation, because although we are safe, the event might quietly transform our part of the galaxy. Betelgeuse is old, huge, and mighty, and now it's dying. A harsh reminder that even the brightest stars have a lifespan. But in this death, something greater is born. The blast scatters the seeds of new worlds, carbon, oxygen, and iron, that will eventually coalesce into planets, oceans, even life itself. Not destruction at all. Cosmic renewal. And through Webb, we are fortunate witnesses to the rebirth of the universe, supernova by supernova. Amidst Webb's trove of information, scientists discovered something unexpected. Anomalous changes in the chemistry of the expelled material. In addition to the more common elements such as carbon and iron, the blast is launching rare materials, such as technetium and yttrium, into space. These are only able to exist in the intense heat and pressure of a stellar explosion. By their existence, scientists can chart the cycle of life for matter in the Milky Way, from the core of dead stars to the dust that builds planets, to the atoms that make up our own bodies. Webb is not merely documenting a cosmic occurrence. It is decoding the molecular recipe for life itself. Betelgeuse will never be the same again. Its position in Orion will become an expanding nebula of incandescent debris. But this is not the end of the tale. It's the start of a new one. Its demise is a gift of knowledge, of insight, of perspective. It makes us remember that even our own sun will one day dwindle, that even the longest burning lights in the sky are not forever. Yet, in their demise, they create everything that follows. No supernovae, no planets, no seas, no life. Now, with the James Webb Space Telescope, we finally get to see that complete process, from blazing oblivion to seeds of creation. In a frozen desolation of distant space, 642 light-years away, a star died, albeit not in peace, but in a glorious cosmic scream that traveled centuries to reach us. This time, we were prepared. With Webb, we did not merely witness it, we comprehended it. The collapse, the energy, the transmutation, not as mythology or metaphor, but as empirical fact. Betelgeuse's last act has provided us with answers to questions as ancient as humanity itself. Where are we from? How do stars die? What's next? Within that dying red glow, Webb has recorded more than the dying of a star. It recorded our cosmic birth story, and perhaps even a glance at our destiny. Let us know what you think in the comments. Was this the most important stellar event of our time? And what will be the next cosmic secret the James Webb Telescope reveals? Subscribe and turn on notifications because this isn't the end. It's the beginning of what comes after the stars.